Hello and welcome back. Today we're going to be looking at lesson 2-4. It's titled It Works Like Magic, and this section is about dimensional analysis. It's a way of converting measurements. It's maybe one of the more challenging lessons, but it's also one of my favorites. Towards right above where the class stuff is, it does talk about what dimensional analysis is. It is the process of converting units. Where the classwork starts, they reference the unit equivalence table in the prep skills. This is on page 196. You might want to mark that page. It's going to be a valuable page to use because it has a lot of our measurement conversions that we can use to do these dimensional analysis conversions. So one thing they talk about is that in that chart, we saw that 1 kilogram is equal to 2.2 pounds. Well, that's great to know, but we don't always know which way I want to write that conversion factor. If I want to write it as 1 kilogram over 2.2 pounds or 2.2 pounds over 1 kilogram. And we're going to work our way through some problems to kind of show me how to determine which one I would need to use. We call those fractions conversion factors. They mean the same thing. So 1 kilogram over 2.2 pounds is the same fraction as 2.2 pounds over 1 kilogram. They're just written in different ways. And it's essentially 1. And because it's 1, it doesn't actually change the number that we're working with. So at the very bottom of this page, they tell me that we are working with 450 milliliters of Dr. Fail's Magic Love Potion. So we're going to be converting that into liters. So the first thing they asked me to do in number 1, he's going to walk me through the steps on how to begin this dimensional analysis, is the two conversion factors showing that 1 liter equals 1,000 milliliters. So he's telling me right here that 1 liter is equal to 1,000 milliliters. I can write that as two different fractions. I can write 1,000 milliliters on top over 1 liter on the bottom. Or I can write 1 liter over 1,000 milliliters. These are both correct conversion factors to convert between liters and milliliters. In number 2, they show me how it would work if I used either of my conversion factors. So in the first one, I am taking 450 milliliters and I'm using the second conversion factor I wrote. In the first one, I'm taking 450 milliliters and we're trying to use the first conversion factor I wrote. There's a little math note here on the side that reminds us that when we're dealing with fractions, anything on top will cancel with anything on the bottom. So that shows me right away that the first one is the better one because milliliters will cancel and I'll be left with liters. So this is the way we want to do it. That is the correct one because if I do the other one, nothing cancels and I end up with milliliters times milliliters, which is milliliters squared over liters, and that means nothing. There's nothing we understand, it's nothing we know. So we definitely want to use the first calculation. I tend to do this. We just answered number 3. The units for the second calculation would be milliliters squared over liters, and that has no meaning for anything we know. All right, now they want us to do the conversion that we have, that we wrote, the first one that we said was correct. So I am going to multiply everything that's on top. So 450 times 1 is 450. And then I'm going to multiply everything on the bottom. That one's a little bit easier because the only thing on the bottom is 1,000. And then I'm going to divide them out. If I take 450 divided by 1,000, I can do it in my calculator. 450 divided by 1,000. I get an answer of 0.45. So my answer is 450 milliliters is 0.45 liters. Number 5 gives us another conversion. They tell me that 1 gallon is equal to 3.79 liters. And again, they want me to write the two different conversion factors. So I can write 1 gallon on top over 3.79 liters on the bottom. Or I can flip it. I can put 3.79 liters on top and 1 gallon on the bottom. They are both correct conversion factors. The one we choose to use is going to depend on what I'm trying to get to cancel out. In the first one, I have liters on the bottom, so that will cancel with liters on the top. In the second one, I have gallons on the bottom, so that will cancel with gallons on the top. So let's see what they're asking us to do. They're asking us to take our answer from question 4. So I'll go ahead and write that back in red since that's what we had it in there, 0.45 liters. And we want to convert that into gallons. So the question is, which conversion factor do I want? Well, I have liters on top. I want liters to cancel out. So where does liters need to go? On the bottom. So it's going to be that first conversion factor. So I'm going to multiply this by 1 gallon over 3.79 liters. Just like before, I'm going to multiply everything on top and write it down. That one's not too bad. 0.45 times 1 is 0.45. I'm going to multiply everything on the bottom, and I promise you they will get longer. These are sort of short ones right now. 3.79. And then I'm going to divide it out. And I will get out my calculator to do that. So we take the 0.45 divided by 3.79. And I get this, and they do ask me to round to the nearest hundredth place. So 0.118, let's write that down so we can show you how to round. They want me to round to the hundredths place, which is two numbers after the decimal point. That's where they want me to round to. The 8 is going to tell the 1 what to do. Well, since the 8 is bigger than 5 or bigger, it's going to tell the 1 to bump up. So I have 0.12 gallons. That's number 6. Moving to the next page for number 7. This is page 201. This is where the fun starts. This is the magic. This is one of the great things about dimensional analysis. It took us 2 steps to get from 450 milliliters into gallons. First, we converted to liters, from milliliters to liters, and then we went from liters to gallons. But we could do this all in one step. That's the beauty of dimensional analysis. And I recently heard a new way of doing these, and it's called train track problems. I have 3 kids, and my youngest learned them this way, and I think it's kind of a cool way to do it. It's just a shorthand way of writing the fractions without having to write fraction bars each time. And I'm going to recall that we are starting with 450 milliliters. And I'm trying to get into gallons. I'd like to end with gallons. So rather than doing it in 2 steps, I can do it in one long step. So the first thing I want to do is get rid of milliliters, because I know how to convert between liters and gallons, but not milliliters and gallons. Milliliters is on top, so where does it need to go to cancel out? It needs to go on the bottom. So I'm going to put milliliters on the bottom and liters on the top. And then I look back at page 196, and I know that 1 liter is 1,000 milliliters. So now I'll get out my crossing out pencil. Let's do that in pink. And milliliters cancels. I'm at gallons, so I'm not ready to stop yet. I need to do it again so that I can get rid of gallons. Or I can get rid of liters and turn it into gallons. Liters is on top. Where does it need to go to cancel out? It needs to go on the bottom. Remember, with fractions, top cancels with bottom. So I want liters on the bottom and gallons on top. And I remember from that previous problem that 1 gallon is 3.79 liters. And again, I can look back at page 196 for that. Get out my crossing out pencil. Now liters will cancel. I'm left with gallons. That's where I wanted to be. So I'm excited. I'm happy. I have some train tracks I didn't use. That's okay. Now I'm ready to do the arithmetic. The setup is the hardest part of these. The arithmetic is really just multiplying and dividing. I'm going to multiply everything on top. 450 times 1 times 1. So that's 450. And then I'm going to multiply everything on the bottom. So I think I might need my calculator for that one. 1,000 times 3.79 gives me 3,790. And now we're at our very last step. This is the fun step. Take the top divided by the bottom. So take 450 divided by 3,790. And there's the same answer we got. So that's 0.12 gallons again. So number 8, we're going to do another conversion. We're going to convert miles into inches. And we're going to do it with all in one step like we just did in number 7. So I'm going to go ahead and set up my train tracks. Again, I can always have too many, that's okay. Just don't have to use all of them. And let's write in the top left corner what we're converting. He says my house is 15 miles, so that's what we're converting. And I'm trying to get into inches. Not sure why, but we're trying to get into inches. If I look back at page 196, I have a conversion between miles and feet to inches. I don't have anything between miles and inches, so I'm going to have to do it in 2 steps. Miles is on top. Where does it need to go to cancel out? On the bottom. So I'm going to put miles on the bottom and feet on top. And then on page 196, they tell me that 1 mile is 5280 feet. Get out my cross-off pencil. Miles cancels. I'm at feet. I'm not done yet, so I have to do another round of this. Now I want feet to go away. Feet is on top, so I need to put feet on the bottom. And I do know that I can convert between feet and inches. I know that 1 foot is 12 inches, or I can look at page 196 and they'll tell me that. So now feet cancel. I'm left with inches. I breathe a sigh of relief because I'm almost done. I've gotten all the setup right. Now I just need to do the math, the arithmetic part. And again, that consists of multiplying everything on top. Definitely want my calculator for that. So I'm going to take 15 times 5,280 times 12. And I get something very large. I get 950,400. So 950,400. Now we should at least acknowledge that we've thought about the bottom. The bottom's all ones. So I divide by 1. So my answer is done. It's 950,400 inches. Which I don't think you'd ever want to measure that way. Towards the bottom of page 201, they talk a little bit about the metric system. Metric system is very useful. If you go into a different country, you're going to see a lot of stuff measured in metric system. And they do talk about how to go back and forth within the metric system. So instead of using dimensional analysis to convert 450 milliliters into liters, we could have just looked at the conversion chart on page 196. And I noticed that going from milliliters to liters is a move 3 columns to the left. So I could have just moved my decimal 3 places over and turned 450 into 0.45. And if you go to the right, that's how far you'd move to the right. So they're, in number 9, they're asking us to do 2 things. We're taking 0.44 liters. In the first one, oops, I didn't finish my 4. We're converting into deciliters. Well, I know that deciliters is 1 column to the right of the base unit. So I'm going to take my decimal and move it 1 place to the right, leaving me with 4.4 deciliters. Let's take the same number in liters and turn it into kiloliters. Well, to do this one, I know that I have to move 3 places to the left. The kilo column is 3 columns to the left of the base unit, so I have to move this 3 spaces to the left. 1, 2, 3. So I have 0.0044. And I didn't write my last 4, that's weird. Let me skip that a second, I have to change something here. I missed a 0 too. There we go. So I have 1, 2, 3. I fill in the ones that did not have zeros with zeros. So I have a 0 decimal point and then 3 zeros and then the 4. It's a really tiny number. It's probably not a very practical way of measuring because it's so tiny. So probably the preferred way to measure it would be definitely in deciliters. That's going to be much easier to measure if I have to have something measured in deciliters. But the 0.00044 is really tiny. All right, going to page 202. They tell me that Dr. Fail's potion also comes in a 0.75 gallon container. We want to convert that to cubic centimeters using the equivalents in the prep skills table and dimensional analysis. And they tell me something that I'm going to need here, that 1 cubic centimeter is 1 milliliter. I did not know that until I had little kids and I was giving them medicines. I was like, oh, that's cool. I'm going to go ahead and set up the train tracks here, just because it's definitely my preferred method for doing it. Again, it's a shortcut way of writing the fractions. I can start out with a whole bunch of train tracks. If I don't use them all, no big deal, I leave them blank. So I'm starting with 0.75 gallons. And I'm trying to convert that into cc's, which is the same as milliliters. So cc's or milliliters, because they're the same thing. Well, the first thing I need to know is I need to get out of our system and get into the metric system. So I'd like to get it from gallons to liters. We just did that on the previous page. Gallons is on top. So where does gallons need to go so it cancels out? On the bottom. So I know from what we were working with before and the chart on the previous page, I can convert between gallons and liters. I know that 1 gallon is 3.79 liters. Get out my little pen to cross things off with. Gallons cancels, but I'm not done because I haven't made it into milliliters yet. So now I want to turn liters into milliliters. Liters is on the top, so where does it need to go to cancel out? If liters is on top, it needs to go on the bottom. And I do know I can convert between liters and milliliters. I know that 1 liter is 1,000 milliliters. Now I can cross off my liters. I'm left with milliliters, which is really where I wanted to end. If you want to be super precise, you can put milliliters on the bottom and cc's on top, and then just put ones in because they're the same thing. So that would work as well, because then you are officially at cc's. When I get to this point, I'm happy, because now all I have to do is throw it in my calculator. Multiply everything on top. So let's get out the calculator. 0.75 times 3.79 times 1,000 times 1. And I get 2,842.5. So 2,842.5. And kind of like that other problem, we should verify that we've looked at the bottom at least. In this case, the bottom is all ones, so my conversion is done. So 0.75 gallons is 2,842.5 cc's. Here's another thing we can look at. This idea of cubic centimeters. cc's means cubic centimeters. So according to the table of equivalencies, 1 inch is equal to 2.5 centimeters. What would the result of this calculation be? So just like before, we're going to multiply everything on top, which is kind of nice in this case. I get 1,000 times 1 times 1 times 1, or 1,000. Multiply everything on the bottom. So 2.54 times 2.54 times 2.54. I'm going to cheat and use a power. So 2.54 raised to the third power, except I got to get the power in there. Raised to the third power. That's a shorthand way of writing 2.54 times itself 3 times. I get 16.38. Or let's see, we'll put in as much as we can. 16.3871. Let's say that. And now let's take the top divided by the bottom, the green divided by the purple. So 1,000 divided by 16.38 16.3871. And they asked me to round it to the nearest whole number, I believe. Yeah, to the nearest unit. I get about 61 inches cubed. So 1,000 cubic centimeters would be the same as 61 cubic inches. Why in the world might we want to do this? Where's this pertain to? Well, we can take our answer from number 10 and convert it into inches cubed if we ever wanted to. So again, I'm going to get my train tracks here. Okay, just do a whole bunch of them because I may need several this time. I am trying to convert my answer from number 10, which was the 2,842.5 inches cubed. And I'm trying to get that into centimeters cubed, cc's. So the trick is I have inches on the top. I definitely need inches on the bottom. So I can convert between inches and centimeters because they do give me that on page 196. The trick is I don't just have inches on the top. I have inches to the third power. That's inches, inches, inches. So if I have inches 3 times on the top, how many times do I need inches on the bottom? 3 times. So I'm going to do the same conversion here 3 times. We know from the previous problem that 1 inch is 2.54 centimeters. Oh, I have an issue. Let's fix my issue real quickly. And I'll fix these as well. I wrote the problem down wrong I wrote the label down wrong from number 10. So let's go back and fix that. The 2,842.5 in number 10 was cubic centimeters. I knew something wasn't looking right. This is going to be really big numbers. So I have centimeters to the third power on top. If I have centimeters on top to cancel out, I need centimeters on the bottom. Now we look better. But I don't just have centimeters on top. I have cubic centimeters, which is centimeters, centimeters, centimeters. So I do need to repeat this 3 times. You'll see that labels are very important in this section. And I know that 1 inch is 2.54 centimeters. I just know that from the problem above. So I'm going to do that 3 times. And now I'm going to multiply everything on top. That one's kind of nice because there's a bunch of ones. So I'm going to have 2,842.5 divided by, multiply everything from the bottom, which I can use. I did that already in the problem above. We did 2.54 times 2.54 times 2.54 and got the 16.3871. And now finally I need to divide those out. So let's take 2,842.5 divided by 16.3871. Helps if I type all the numbers in. That's an issue with the touchscreen calculator. 3871. And I get an answer of 173.45. That would round to 173.5. And that is my answer in inches cubed. Kind of a less practical measurement. cc's are something you actually measure liquids in a little more often. Now, 13 says, hey, look at that shortcut you did. What number do you see written in both 11 and 12 in purple? You see this. So rather than doing 2.54 times 2.54 times 2.54, I could have just divided by 16.3871 or 16.39. They round to 16.39, but that's coming from our number. They just rounded a little closer than we did. Honestly, I don't mind writing it out. It makes more sense to me logically, so I'd probably do that most of the time. There's a nice worked out example for you here. So you can work through that and do some more practice. Again, they do talk about that idea of if I have inches twice on top, I need inches twice on the bottom. If I have it 3 times, I need it 3 times. It has to be the same number of times to cancel out. So you will get to practice some more of this in your groups. You'll get to practice a lot more of this on your homework, and hopefully you'll get a lot more comfortable with it and kind of see where the magic starts, because it is kind of cool.